Dear friends, today we will discuss uniform electric field and charge, single charge as well as dipole in uniform electric field. First let's start from uniform electric field. What do you mean by uniform electric field? The electric field at every point of which electric field intensity is same. It's called uniform electric field. Electric field intensity is same at every point. Electric field intensity is a scalar or vector quantity? It's a vector quantity. So as it is a vector quantity, if it is same, it has to same both in magnitude as well as direction. So how will present uniform electric field? By drawing electric field lines. How will present it? We will present it like this. You see, I have presented uniform electric field like this. So this is equidistance parallel lines, equispaced parallel lines. What is, you see, equidistance, these distances are same. These distances are same, equidistance parallel lines. The question now may come to your brain, why equidistance parallel line? Just before I told you, electric field intensity is same, means same is both magnitude as well as direction. So why I have taken equidistance? It cannot be like this. Can it be like this? See, can it be like this? Any problem will happen? Why it is equidistance? Because I have told you in one property of electric field lines. You just recall that one. One property I have told you. The region where electric field lines are crowded, intensity is more. So here at every point you see electric field lines equidistance. Nowhere it is crowded, non-uniformly crowded there. So intensity is same at every point. But here you see, at this region lines of forces are crowded. At this region they are rarefied here. So here intensity will be more and here intensity will be less in magnitude. Here magnitude will be more, here magnitude will be less. So that's why it is taken equidistance. I hope you understand why it is taken equidistance, to have same magnitude. Then why these are the parallel lines? If they will be parallel line, then direction will be same. Now it is clear. So uniform electric field is represented by equidistance parallel lines. Equidistance to have same magnitude, parallel line to have same direction. Now is it clear? Okay. Now next come to what is but this type of electric field, does it exist in universe? The question may come to brain. Does it exist in real life? Yes. You just recall while drawing the lines of forces where I have drawn this type of electric field, where I have drawn this type of lines of force. You just recall this figure, one plate, positive plate, negative plate. There I have drawn this type of lines of force. You just remind. See. So this uniform electric field exists between two charged plates. This is nothing but capacitor. But this capacitor we will discuss in the next chapter. But at that time again I will recall you. So I will remind you at that time that where uniform electric field exists. In real life it exists between the capacitor, between two plates of capacitor. Okay, now come to non-uniform electric field. The electric field which is not uniform is called a non-uniform. Means electric field intensity is not same. If it is not same means neither in magnitude. If any one will not be same. If magnitude not same, then it is also non-uniform. If direction is not same, it is also non-uniform. You see. So non-uniform electric field is this. This is now the example of non-uniform electric field. So here magnitude is not same, but direction is same, but magnitude is not same. So this is one non-uniform electric field. Parallel lines, non-uniform electric field. This is also one non-uniform electric field. Convergent. This is also one non-uniform electric field. This is divergent. So I have drawn here three types of non-uniform electric field. It can be many types also. You see, this is parallel. Here magnitude same, but here magnitude different, but direction same. Here both are different. Here also both are different. Convergent and this is divergent. But our point is now, if we keep a single charge in uniform electric field, what will happen? Now we'll go to that one. But single charge, how we keep? We may keep the single charge at rest, or the single charge may enter into the uniform electric field. Now let us see. If I keep a single charge, this is uniform electric field, equidistance, parallel lines. If I keep a single charge at rest, first we'll discuss at rest. Then what will happen? At rest, initial velocity 0. When the charge is kept inside it, this is uniform electric field intensity E at every point same. So now this will experience force. You know, this is the definition of electric field. When charge is kept, it must experience force. So how much force it experience? F is equal to QE. This is the force experienced inside the electric field. If this is the force, what is the acceleration? QE by M. Force by mass. So this is the acceleration. Now you see the acceleration, magnitude, Q is constant, E is constant, M is constant. Is the acceleration constant? Yes, this acceleration is constant. As acceleration is constant, so all the equations of motion are valid for this. What equations you had written in class 11th? V is equal to U plus T, S is equal to U T plus half T square, V square minus C square equal to S, something, all equations now are valid for this. So now the questions will come, combo questions will come relating the equations of motion and electric field. You can face the combo questions like this. One question you will find in your NCERT book, example 1.8. You can solve that question. Okay. But here, if this charge is positive, where it move along the field, because force and field are in same direction. I have told you already. If this charge is negative, where it move opposite to electric field, because force and electric field will be opposite direction. It will move opposite to electric field. So this positive charge move along the electric field, negative charge will move opposite to electric field. And what is the trajectory of the charged particle? It's very clear, only one force acts. So the trajectory is a straight line. That means when a charged particle is kept at rest in uniform electric field, the trajectory is a straight line either along the field or opposite to field. If charge is positive, along the field. If charge is negative, opposite to field. Now this is about single charge in uniform electric field. Now we come to when it is this single charge, but when enter with some velocity perpendicular to uniform electric field, what happens? This is one charge plate, this is one plate. Here uniform electric field exists, you see. I have drawn in downward direction. If you don't like, you can also draw in upward direction, no problem. Okay, so this is the electric field exists. Uniform electric field equidistance and direction same. One charge particle, this is positive plate. I have drawn positive plate, this is negative plate. Already I have told you between two positive plate and negative plate, between this plate electric field is uniform. This plate also you may not draw, not important. But here one charge particle enter with some velocity u. Enter perpendicular to uniform electric field. Now I want to see what will be the trajectory. Let us see. This is a good question. Okay. So this one is actually your NCERT book example 33. Not example, exercise 33. NCERT book exercise 33 is this question. I am indirectly solving that NCERT book 33 question. It's a good derivation also. One type of can be derivation of 2 mark may come in your board examinations. Let us see. U is the initial velocity. It enter into the electric field. When it just enter into the electric field, immediately force act on the charge particle. Charge particle is Q. Force act in which direction? If Q is positive, force act along the field. Let us take Q positive. If Q positive, force act along the field. Force act in this direction. Along the field. This is the field direction. Force act along the field direction. It has its velocity like this. Force act in this direction. Means acceleration also will be in this direction. How the particle will move now? What was the initial velocity along this y-axis? Along x-axis, velocity is u. But along y-axis, what is the initial velocity? It is 0. But now due to force on acceleration come, and along y-axis the velocity gradually increase. So it has now 2 velocities. One is along x-axis, one is along y-axis. How the particle will move? Particle will move along the resultant. So how will the path? You just remind class 11th. This one from a tower. When you throw a body with some velocity u, one velocity is horizontal u, one acceleration comes in downward direction, acceleration g. How the body move from the tower? The body move from the tower like this. The same situation happens here. Initial velocity u, acceleration will be in this direction. The body now, the charge particle now will move like this. In this path now, charge particle will move. And what is the shape of this path? In 11th class you have read the shape is parabola. The trajectory is then parabolic. Just I am going to prove that the trajectory is parabolic. But geometrically we understand it must come as a parabola. Let us see here. So that means you will face the questions here, combo questions from projectile and electric field. Now the question become difficult. Combo questions will come from projectile and electric field. What equations are valid for projectile? All equations of projectile will be applicable here. So now let us see, we will prove this. What is the equation of trajectory? Now we will find. See along x-axis. Along x-axis, what is the velocity? Velocity is u. What is the distance covered? Let us take the distance covered along x-axis is, this distance is along x-axis is covered. Let us take that x. So distance covered is x, velocity is u, time taken is, let us take the time as t. Then velocity is equal to distance by time. Simply there is no acceleration along this line. This u velocity always remains constant because force acts perpendicular to it. So this u velocity always remains constant. So horizontal velocity that always remains constant. So implies that t is equal to x by u. Now come to along y-axis. Force act here F. So what is the force? F equal to QE. What is the acceleration? QE by m. This is the acceleration along which axis? Along y-axis. If this is the acceleration, then what is the equation of motion? The distance covered along y-axis terms. This is the distance covered along y-axis y. So S is equal to, S means y, ut, but u is 0. Along y-axis there is no velocity. This velocity u is along x-axis. Along y-axis initial velocity is 0. So ut plus half a t square. But y, what is half a, bring from there qe by m into t square. But t bring from the equation number 1. x square by u square. Now you got one equation here. So this equation you see y is equal to qe by 2mu square into x square. So this bracket term is constant. Q constant, e constant, m constant, u is the initial velocity that is constant. So this is kx square. What is this equation? This is the equation of a parabola. So the trajectory is parabolic. So now it is proved how the path is parabolic. The question may come in exam. A charged particle enter perpendicular to uniform electric field. Prove that the trajectory followed by the particle is parabola. This is proved is done. Or I have told you your NCERT book exercise question 33 is given to prove this. The symbol may little change to prove this one. You can do that one. Now will come one question here, one concept here. One question may come. You see why is the vertical displacement? Particle goes like this, but it displaces like this. So this y distance it falls along the vertical. So you see for constant x, e x square to u square. For constant x for different particles. For constant x for different particles, you see the vertical deflection depends on q by m ratio. One concept you can get here to solve some questions. The vertical deflection depends on q by m ratio of a particle. More is the charge to mass ratio, more is the vertical deflection for constant x, for same x. For same x, y directly proportional q by m for same x for different particles. Basically this concept you can solve your NCERT book exercise question number 1.14. There is a figure. From the figure you can see more is the vertical deflection, more is the q by m ratio. Okay, now we will go to the, this is over. Now we will go to dipole in uniform electric field. Another thing I am telling you, based on this formula, one numerical is also there. Your last question of NCERT book, question number 34. That is a numerical based question based on this formula. We can also solve that question. Question number 34, last question. Okay, now we'll go to the important part, very important part of 12th class. I am adding now one more derivation in your topic. Already we have discussed two derivations about electric dipole. I will discuss another very important derivation, torque on a dipole in uniform electric field. This is a very important one. Let us draw one uniform electric field. Always comes in board exam. It is very important one. Let us concentrate. Dipole in uniform electric field. This is a dipole. Minus q plus q. Where is the dipole moment direction? Yeah. So this is the electric field intensity E. Let us take the angle between intensity and dipole moment as theta. This is the angle between dipole moment and intensity theta. But some students do a common mistake in plus q and minus q. If I by mistake I will do this plus q and I will do this minus q, then dipole moment will be in the downward direction like this. Then theta will not be the angle between E and dipole moment. Remember, if you are writing this angle as theta between dipole moment and electric field, then you have to write this as minus q and this as plus q. So that dipole moment will be this direction. Then now theta is the angle. Okay. So now let us see. If the dipole is kept here, the charges individually experience force. What is the force experienced by plus q? Let us see. Force experienced by plus q in which direction? This direction. F1 vector. And what is the magnitude? Q for u vector. Q is already I have told you. If positive charge, force and electric field are the same direction. What is the force experienced by minus q? So minus qe. So automatically this minus sign indicate force and electric field are in opposite direction. Charge is negative, force is opposite to electric field. So these are the two forces experienced by the two charged particles individually. What is the net force? F vector equal to F1 vector plus F2 vector. They are equal in magnitude, opposite in direction. What will the net force now? 0. If net force is 0, there is no movement of the dipole. The center of mass of the dipole will not move. The dipole cannot execute translatory motion. It cannot shift from one place to another place. Net force is 0. So no translatory motion. It cannot shift. But what happens more here? It cannot shift. But what else happens here? You see, two forces are not in the same line of action. They constitute a couple due to which dipole rotates. Now the word couple is coming here. In 11th class you have read in rotation chapter about couple. Okay, I am just telling a little about 11th class. If you have neglected in 11th class, then no problem, you can able to understand. You think this is a rod. In this rod I apply one force here, one force here. The net force on the rod will be 0. This is the center of the rod. Net force will be 0. Will the rod move anywhere? No. Is there any movement of the rod? Nothing happen. You can just try keeping your pen like this. You keep your pen, apply two forces in opposite direction. Suppose I will just shift the forces. You see, I shift the force here, I shift the force here. Now what happens? You keep your pen and apply two forces like this. What happens to your pen now? It is rotating. This is called a couple. And the two forces are not in same line of action, but initially they were in the same line. But now its line is here, its line is here. They are not in the same line of action. When two forces equal in magnitude, opposite in direction, not in same line of action, then they constitute a couple, due to which the body rotates. Here the same thing happen. You see, this is dipole. They are not in same line. Its line is here. Its F2 line is this one. F1 line is this one. So they constitute a couple, due to which dipole rotate. Now let us calculate how much couple act here. Means torque. Moment of a couple is called torque. It is measured by a quantity called torque. You have read in class 11. Okay. So what is the torque? Torque is magnitude of either force. Torque is magnitude of either force into perpendicular distance. What is magnitude of either force here? Both forces are same. The magnitude is QE. What is perpendicular distance? This is the perpendicular distance. You see, this line is this line. This is the perpendicular distance. Let us name it ABC. The perpendicular distance from the figure is clear. It's BC. So you place equal to QE. What is BC? BC now you see from the figure, it is AB sin theta. You can see sin theta is equal to BC by AB. Sin theta is equal to BC by AB. So this is equal to AB sin theta. And what is AB? AB is nothing but length of the dipole. We are taking 12 sin theta. So Q into 12 is which quantity? This is B. Q into 12 is which quantity? Dipole moment P. P is sin theta. Torque. This is the expression of the torque on the dipole in uniform electric field. P is sin theta. But dipole moment is a vector quantity, electric field is a vector quantity, and sin theta is here. Vector sin theta. I think it's a, you are reminding the formula in 11th class vector. This is product formula. Which product of sin theta is there? Obviously cross product. So tau is also a which quantity? Vector quantity. Tau is also a vector quantity. Now let us write its vector form. All in exam, when this derivation come, many questions are attached in this. I am discussing what questions also will be attached here. This the torque derivation is complete, but what questions will attach? It will give right vector form of a torque. Tau vector is equal to P vector cross E vector. You will write P vector cross E vector. Okay. Then the question will ask, where is the direction of the torque? Torque direction will find by our right hand thumb rule. Here is the dipole moment. Here is the electric field. you see dipole moment and electric field. You can do like this. Torque will be perpendicular to the plane inward. If this is the dipole moment, this is the electric field, the angle between them is theta, and you rotate like this. Okay, P cross E. Where is the torque direction? Perpendicular to the plane inward. It's clearly you can mention perpendicular to the plane inward, or you can write perpendicular to the plane containing P vector and E vector. Containing P vector and E vector. So this is about direction. This is one question may come. Where is the direction of torque? Or one question may come. Write the perpendicular which vector, which pair of vectors are perpendicular. Tau vector perpendicular P vector and tau vector perpendicular E vector. This can be a question. This can be a question. This can be a question. Tau, write the pair of perpendicular vectors. Tau P perpendicular, tau E perpendicular. What more questions also you can ask here? One more question I am discussing also. Let us come. One important question always asked here. If this electric field is not constant, non-uniform electric field, what happens to the dipole? If when dipole is kept in a non-uniform electric field, what happens? If we keep the dipole in a non-uniform electric field, these two forces will not be same because electric field will not be same. These two forces is not same. Now net force is not 0. If net force is not 0, what will happen? The dipole execute translatory motion. The dipole execute translatory motion, and if it is at some angle with electric field, it also execute rotational motion. It also execute rotational motion. So you can write the dipole will execute, if when the dipole is kept in non-uniform electric field, it execute translatory motion and may rotational motion. May be rotational motion. It's clear? Now we come to the different cases. As theta angle is here, let us discuss the different cases here. What different cases will come? So if theta is 0, what will happen? P is sin theta, P is sin 0, P is sin 0, what is the value of sin 0? 0, so torque is 0. I am discussing now, it's a special case. Torque will be 0. If torque is 0, what happened here? Initially force 0, initially always force 0 in uniform electric field, otherwise torque 0. This is the condition of stable equilibrium. And how the dipole will remain? This is the electric field. Dipole is like this. This is dipole moment direction, minus q plus q. Dipole remain like this. This is the stable equilibrium condition. One question have come once to draw the orientation of electric field and dipole moment when it is stable equilibrium. You can draw the figure like this. Stable equilibrium. What do you mean by stable equilibrium? Now the question may come to your brain. You have read in class 11th, but I think you forgot. Stable equilibrium. Stable equilibrium means if a body is at one position, you slightly disturb it. After disturbance, if it returns back to its position, then that is called stable equilibrium. It returns back to its own position, then it's stable equilibrium. One example I am telling you, you see one curve, this is your T curve, one ball is there, you just disturb the ball get disturbed, again return back to its position. It is called stable equilibrium. Another example I am telling you, North Pole and South Pole of two magnets. They attract each other. This is in stable equilibrium now. Suppose you just push the south pole. If you push the south pole, what will happen? The magnet will be like this. Again, when you leave it, again return back. This is called stable equilibrium. Okay. So when the dipole is like this, you see it is in this position along the electric field. If you disturb it and leave it, again the dipole return back to its position. If you disturb like this, also return back to its position. always they prefer to remain parallel to electric field. This is the stable equilibrium position. In exam question come, what is stable equilibrium position, or when stable equilibrium, what is the angle between dipole moment and electric field? Theta is equal to 0. Then come to theta is equal to 180 degree. Also tau is equal to 0 because P sin 180 0. Initially force 0. Here also force 0, torque 0, both 0. But this is equilibrium, but unstable equilibrium position. Unstable equilibrium position. What is unstable equilibrium position? This one. So this is your curve. Keep a ball here, ball will remain balanced, no problem. But if you disturb, the ball will fall down. Can the ball rise itself? No. But the ball was in equilibrium. But when you disturb it, it changes the position completely. This is unstable equilibrium. You see, by pushing from both sides, by applying force from both sides, you can keep north pole in contact. Pushing from both sides, you can keep, no problem, they will remain in equilibrium. But when you push the north pole in this direction, what will happen? The north pole will immediately go away from this, it will not return. This is equilibrium, but unstable. This is equilibrium, but unstable. The same situation happens here. This is electric field. Dipole is like this, anti-parallel. What will happen? If this dipole will disturb like this, will it return back? No. If it disturb in this direction, dipole will rotate and return back. We will come to this position. Okay. If it disturb the dipole in this direction, what will happen? Dipole will rotate in this way and come back to this position. Come back to this position. It will, the dipole will remain like this, but if you disturb slightly, it will change its position completely. It comes to the stable equilibrium position. So this is theta is equal to 180, unstable equilibrium position. But when theta is 90 degree, what will happen? Theta is 90 degree. What is the torque now? P sin 91. This is the maximum torque act on the dipole when kept in uniform electric field. Is it clear? So this is about the torque on the dipole in uniform electric field. But based on this, you can do one question from NCERT book. Very important question. Question number 27, 1.27. Question is very important question from NCERT book. You can try. Also, I discuss one question this time in 2020 board examination came from about this torque. 1 Hertz came up 3 marks in board examination 2020. I will discuss that question in my next video. Thank you.